Hi, in this video we will talk about another category of function, which is very common in algebra, and this is called exponential functions. First, we will define what an exponential function is. And the exponential function f, or an exponential function f with base b, is defined by, so that function f called exponential function is defined by this equation: f of x equals b raised to x, or you can have y equals b of x, so you can replace f of x by y, so it's okay, where b is a positive constant. So uh, remember b is a positive constant, so this is a positive number, okay, other than 1. So it means b must not be equal to 1. It can be any positive number greater than 0, but should not be equal to 1. And remember that x is any real number. So the variable here is clearly the x. Okay, so this is the only value that will change. Okay, so this is the exponent. That's the exponent. So b is a constant. Okay, so uh, how does it look like in a graph? Uh, we will consider, but before that, we will consider two cases. Okay, the first case will be if b is greater than 1, and that's the first case. And the second one will be what if your b is between 0 to 1, between 0 and 1. So there are two cases. First, before that, remember that the domain, whatever is the case, the domain of this function f is the set of all real numbers, or this one in interval notation. The range of this exponential function f defined by this is um, this one. So this is the set of all y such that y is greater than 0 . So number 3, we have this one. If b is greater than 0, so we will consider the first case. The first case will be what if your b is greater than 1. Okay, so what if your b here is greater than 1? So what are those numbers greater than 1? Positive numbers greater than 1. It can be uh, any positive. Okay, it will be 1.5 or 2 or 2.99 and so on and so forth. So any positive number greater than 1. So if that b is greater than 1, then the graph of the function f defined by this has a graph that goes up to the right and is an increasing function. So how does it look like? So if we have a function f, exponential function f defined by f of x equals where b, remember b is greater than 1, so let's say so remember b is greater than 1 here, b raised to x. So the appearance of the graph basically looks like this. Okay, and so on. Okay, we can see that one later in our examples. If b is greater than 1, what if your b is between 0 and 1? Okay, so which means the values may be if your b is greater than 0 but less than 1, so what are this b? So it can be 0.5, it can be 0.99, okay, 0.99 or 0.81 and so on. So any number that is between 0 to 1. Okay, so the graph of your f defined by f of x equals b raised to x basically looks like this. Uh, f the appearance of the function f defined by this, where b is between 0 to 1, has a graph that goes down to the right and is decreasing function. So the appearance of that graph basically looks like this, similar to the one we previously graphed, but of decreasing. Okay, so it basically looks like this. So the graph of f defined by this, where b is less than, basically looks like this. Now for if b is greater than 1, so the graph of this function defined by this is basically looks like this. Okay, so whatever is the case, the graph of f of x equals b, or that function f defined by f of x equals b raised to x, approaches but does not cross the x-axis. So in other words, our x-axis here is considered to be the horizontal asymptote. So this one right here, the x-axis itself is the horizontal asymptote. We've already learned what an asymptote is. Okay, so we can try some examples. So let's graph the exponential function f defined by function f defined by f of x equals 2 raised to x. Now remember our b here is 2 is greater than 1, right? Okay, so our b here, our base is greater than 1. So we expect that the appearance of the graph basically looks like this. Okay, this blue one, because our b here is greater than 1, the base. Okay, so we expect that the appearance of the graph, the appearance of the graph looks like this. Okay, so it is increasing. Okay, so let's graph. We need only sample points so that we can connect the curve. Okay, we don't need to plot many points. We need only just 3 or 2, because we already knew the general appearance of the graph. So it might look like this. Okay, so let's graph. And remember, our x-axis is the horizontal asymptote. Okay, that's our y-axis. Okay, so we need only sample points to graph. So we make a table of values here. So this is x, this is our f of x. Remember the domain, okay? The domain of this exponential function is set of all real numbers, okay? So since the domain is the set for this function, the domain is the set of all real numbers, and the range is the set of all numbers between 0 up to infinity. Okay, so for this function, the domain is the set of all real numbers, and the range is between 0 that belongs to this set. Okay, so that's the range. Okay, remember the domain is the set of all real numbers, therefore we can select or we can pick any x. Okay, so here we have, at least we can select 3 points. That would be enough. Okay, let's say we select we pick, because the domain is the set of all real numbers, meaning we can pick any x or any values of x. So let's say I pick, again, we expect that the graph looks like this because our b is greater than 1. Okay, the base is greater than 1. Okay, so let's say you pick -1. Okay, -1. So what's the value if your x is -1? So f -1 of -1, that's 2 raised to -1. That is 1 over 2 raised to 1, or 2 raised, that's 1/2. So 1/2 is 0.5. Alright, so 0.5. So we have a point here. This is x -1, and your f of x is 0.5. Okay. Next, you can select 0. Okay, 0. So f of 0 is 2 raised to 0. 2 raised to 0 is 1. So the value is 1. So meaning if x is 0, your y or f of x is 1. You can pick 1 because the domain again is a set of all real numbers. You can pick any number. So f of 1, so that's 2 raised to 1, so that is 2. So if your x is 1, your f of x is 2. So you have 1, 2. Okay, you can plot these 3 points now and then connect them in a curve that looks like this. Okay. Okay, so -1, 0.5. Okay, let's say this is 1, this is 2. So -1, 0.5, it's here. Next, 0, 1, so 0, 1, and then 1, 2. And then connect all the 3 points with a curve that looks like this. So we connect all of this. So smooth curve. And remember, x-axis is the horizontal asymptote. So this is the graph of the rough sketch of the graph of function f defined by f of x equals 2 raised to x. So that's how you plot. Okay, we can verify this one using our graphing calculator. So let's say y equals 2 raised to x. So this is the graph. indeed, our answer looks like what we have sketched here. As you can see, okay. And what is interesting is that x-axis is indeed the horizontal asymptote. If you zoom in, okay, the graph never touches the x-axis, no matter how far, no matter how you go uh, leftward. So the graph never touches the x-axis. But here it looks like, because of the scaling. But the fact is, x-axis right here is the horizontal asymptote of this graph. Okay? Okay, so that's our answer for number 1. Okay, this is the graph. For number 2, graph the exponential function f defined by f of x equals 1/2 raised to x. So remember, our b now here is 1/2, and 1/2 is obviously a number that is between 0 and 1. Okay, so we expect that the graph goes down to the right and is decreasing function, so it decreases. So we expect that the appearance of the graph looks like this, similar to this. So this is the general appearance of the graph where b is between 0 and 1. So we expect that the graph looks like this. Okay, so all we need to do is just like number 1, we are going to select any point, arbitrary points, at least three may do, and then connect them in a curve that looks like this. Okay, so let's graph. So let's select 3 points, at least 3 points. 3 points may do, or you can select 4 or 5 or more than that, your choice. This is x, this is our f of x. Okay, since the domain of the exponential function, whatever is the case for b, the domain is always the set of all real numbers, right? Now we can select, with that we can select any points, we can select any x. Okay, let's say -1 to make it simple. Okay, -1, 0 may do, and let's say 1. Okay, and then we'll find the corresponding value of f of x. So f of x, so let's say -1, substitute it, we have 1/2 raised to -1. So that would be 1 over 1/2. Okay, remember the rule? If it is raised to -1, that is 1 over a. So if this is our a, of course it's in the denominator. So simplifying, that is equal to 1 divided by 1/2, that's 1 times. The reciprocal of 1/2 is 2, so 1 times 2, that's 2. Alright, so we have 2 here. Therefore, we have a point -1, 2. For 0, so 1/2 raised to 0, any non-zero number raised to 0 is always 1. So the answer is 1. So, yeah, the answer. So we have a point now, 0, 1. X is 0, f of x or y is 1. Next is, if your x is 1, so That's 1/2 raised to 1. So of course the answer is 1/2 or 0.5. Okay. You can use this decimal to make our graphing easy or plotting of points easy. Okay, so we have a point, 3 points here. That would be enough. So let's plot -1, then 2. Okay, so -1, 2. So it's here. Next is 0, 1. Okay, 0, then 1. So it's here. And then 1, 0.5. So 0.5 is here. So this is the, the point. Okay, and connect them using, or connect them with a curve that looks like this, because we are expecting that the graph is decreasing. Okay, because our b here is less than, because 1/2 is, yeah, less than 1 but greater than 0. So in other words, the b here is having that condition. So we expect that the graph looks like this, and then connect them. So we have this one. This is just only a rough sketch. And remember, x is our horizontal asymptote, okay, x-axis. So the graph never touches this x, never touches this x-axis, okay? So we have our answer. This is the graph of, I'm sorry. This is the graph of our f defined by this. Let's verify this one using our graphing calculator. 1/2 raised to x. One half raised to raised to x. So this is the graph. Okay, as you can see, this is the graph. So it looks like this. It's not so perfect, but at least we have the rough sketch of the graph. Okay. So as you can see, they're just the same. And of course, our x-axis is the horizontal asymptote. So it never touches. It looks like, but it never touches. So this is the graph of f defined by f of x raised to 1/2 raised to x. Okay, this is the graph of our f. So that would be all for the first part of the video. Please stay tuned for the second part. This is again all about exponential functions. So thank you very much and have a nice day.